Good morning, good afternoon, or good evening, depending on from where in the world you're joining us today. And welcome to LucidLink's webinar. I'm Peter Thompson, co-founder and CEO of LucidLink. And joining me today on the line is David Bull, Director of Technical Sales. LucidLink was formed to address the challenge of accessing files over distance, and specifically how to mitigate the problem of latency when doing so. And this problem is particularly evident when it comes to teams collaborating on big files and large data sets. Even though over the last 10 years we've seen a tremendous innovation in the development of cloud services, data storage has seen little advancement that specifically deals with this problem. And today we're going to demonstrate a technology that takes a fresh approach, helping distributed teams collaborate more efficiently on even huge files without having to worry about syncing data or having to download files first. So most of us have experienced at some point firsthand this problem of having to deal with, having to manage the wild growth of unstructured data. And while speaking with hundreds of customers over the last couple of years, we've noted three other pretty distinct trends. The first is that companies are moving more and more data into object storage systems. And that's both on-prem and in the cloud. This is for a lot of good reasons because object storage has many attractive features. It's very low cost, it's highly durable and elastic, so it grows on demand. And not only that, but people are taking advantage of compute services in the cloud as well. So workloads can be spun up and spun down depending on the requirements. So for example, you may have to leverage GPU-enabled cloud servers to create a scale-out rendering workload. After you're done with that workload, maybe you'll go back to your workstation and perform post-production editing using your own local tools. And then finally, you may need to give access to it to a customer or to a manager to review the final product. This highlights how workflows have become more distributed. But it's not only the workflow, which may be taking place in multiple geographical locations, but it's also workforces. So whether it's through company acquisitions or specializations of the people or using contractors, and just the enablement from modern tools that allow for increasingly distributed workforce, the fact is that it's becoming more the norm rather than the exception to be working with distributed teams on projects. The net result of all this is that now the appropriate data must be made available in more places than ever before, and it must be done so rapidly and securely. And this is very difficult to do because unlike applications, which can be spun up, spun down, and moved around at will, data associated with the application has gravity. And it's become the very difficult part of collaborating, making sure that that data is available to those applications. Now, we noted that object storage is a great place to consolidate all of this data, but because there's no file system associated with it, the performance of it is pretty much unusable when it comes to production. So while it's great for archiving a tier of cold data, if you put a bunch of data in there that you expect you won't have to touch and just archive it over time, it's fine. But we're hearing more and more from customers that they'd like to try to use object storage more for their file-based workloads. And that's exactly where LucidLink comes in. We provide a file system that specifically deals well with high latency environments like the internet, and which allows for object storage to be used in file-based production workloads and remote access. We made it universal, so it would work with all of the major OSs, Windows, Mac, Linux, as well as any object store as the back-end storage. And that's whether on-prem or in the cloud. The architecture provides fast, random read-write streaming access to the files. By this I mean, even if you have a large 10 gig video file, you can just go to the middle of that file and do some editing on it without having to download or sync the entire file first. And we've also taken a very serious approach to security, providing true end-to-end encryption, not just encryption at rest where it's stored. And we build it completely in software and deliver it as a service. And that makes it super simple to deploy and extremely cost-effective. This is how the system architecture looks from a high level. First, we have the LucidLink client, which is depicted in green. This can be installed on a variety of devices, including laptops, desktops, workstations, servers, virtual machines, or even containers. It embeds into the operating system as a file system, providing a view to the data that is in the object storage. Now, it's important to note that this is not just a simple gateway that emulates the underlying object APIs. There are other systems out there that can give you the view into your object storage as files, but in order to use those files, you have to do a full get, or you have to download the entire file before you can use it. And then every edit you make will do a full write of that file back to the object storage, or a put. So going back to that example of video editing, if you have a 10 gigabyte video and you have to download the entire 10 gigs, make a couple of changes in the middle and rewrite it every time, well, this becomes pretty much unusable in a production setting. We've also further optimized the performance by using a sophisticated data prefetching. It's based on our own adaptive algorithm. We open up parallel TCP streams, local write-back caching. We do inline compression. And finally, it also handles the encryption of both file data and metadata. So in other words, we do a lot of stuff to make it really fast and really secure. Now, the object store, the next part of the system, the storage part, here depicted here in blue, is provided by the customer. Our model is bring your own storage. And this means that customers can decide which provider, whether that's on-prem or whether that's in the cloud, is best for their needs. They use their own account with their own credentials, ensuring that they've got complete control over where and how their data is stored. And finally, we have the LucidLink service in orange. This manages the metadata coordination across all of the clients in the global namespace or in the file space. So this means you can have a bunch of clients all collaborating on the same set of data. We manage it all on the back end and on your behalf. This service is completely transparent to users and is provided by LucidLink. We run a discrete service on behalf of every customer file space. So it's about at this point that people begin to wonder how we can achieve all this if we haven't rewritten the laws of physics. And rest assured, there is a logical explanation here. So we already discussed how we utilize a unique streaming file system on top of object storage. So instead of doing full fat gets and puts of very large objects in every object, we stream the file on demand as the application requests it. That's the first part. A second key is in the way we manage and cache the file metadata on each client. So this is instead of relying on, for example, a centralized gateway device, and also in place of old protocols that are usually front-ending those devices, such as NFS and SMB. While those protocols are fine for low latency, high bandwidth networks like a local LAN, they were never intended for high latency networks like the internet. The issue here is that they are really chatty. Oops, sorry about that. The issue here is that they are really chatty, and as distance and latency are injected into the system, the number of round trips that has to go between the application and the metadata of the file begins to stack up. And this is when performance slows to a crawl. If you've ever connected to a file server over a VPN connection and tried to use a file that way in place, you know exactly what I'm talking about. So by caching the metadata on the client, we can remove up to 80% of the round trips and focus on delivering the data efficiently. The result is that you can work with data stored in the cloud as if it's right there on your local hard drive. So what does this mean for users? We speak with a lot of customers who are currently using scale-out NAS devices for a variety of workloads. Here's some of the typical ones, from high-performance computing, data sharing and collaboration amongst teams, user data, backup and archive. And we've already noted that there's a trend of moving cold archive data to object storage. So that bottom one is already happening today. And if it is purely for long-term retention, which will rarely, if ever, be touched again, then there's no real need for LucidLink there. However, there's a portion of that archive data which may indeed need to be accessed on a regular basis. So, for example, in broadcast, news broadcast, where they have a tremendous amount of footage that they need to archive in low-cost elastic storage, but depending on the news cycle of the day, they may need quick access to that archive data. So that's where we come in. They're still able to use the cost-efficient object storage, but we provide them the high-performance access to it from a file basis. Another one is medical imaging in what we would call, these kind of use cases we call active archive. In fact, we have a lot of customers who are now realizing that the majority of their file-based workloads, and that's all but the most demanding high-performance ones, can actually be satisfied on object storage when accessed through a LucidLink file space. Now, don't get me wrong, we believe there will always be a need for ultra-high performance, low latency, flash-based storage and fiber channel networks and things like that for things like high transactional databases or even heavy 8 or 16K video rendering jobs. But imagine if you could move the rest of that into an elastic, low-cost tier without sacrificing usability or performance. For many, that means freeing up to 80% of their high-performance data from their SAN, which in turn allows them to extend the useful life of that SAN or the scale-out NAS, provides significant additional headroom, and even improves the performance of the workloads that are still on it. So at this point, we'd like to show you the product in action. And I'm going to hand the controls over to David Bull, our Technical Sales Director.
Thank you, Peter. Excellent. We'll begin the demonstration with creating a file space. In this environment, you can see we have a number of resources down on the right-hand side, where our main office and/or our remote users are located. We have on the left-hand side our LucidLink file space, which is backed by our S3 compatible object storage. So once we've created our file space, we'll showcase our security. As Peter highlighted, our architecture is highly secure from the client side with end-to-end encryption. We'll provide our user access for collaboration. Now, this again could be internal staff members, branch office remote sales teams, or freelancers and contractors collaborating on data. When adding additional users to a file system, it's important to protect your data. So we'll highlight how we achieve data protection and ensure that your data is securely and protected within your file space. Finally, we'll end with high performance streaming through our unique architecture and data layout that demonstrates how we're able to achieve all that we've discussed this morning so far. Okay, so if I can confirm, Peter, you can see my screen?
Perfectly, David.
Perfect, thank you. We'll begin by just giving you a quick overview of our architecture. We have a Windows machine, and to highlight how universally available our service is, we also have a Mac OS machine and a Linux machine, which we'll use in our collaboration workflow. So if we start off on our Windows machine, we'll begin by creating a file space. Now, when you create a file space, you have two choices: LucidLink storage or bring your own storage provider, so you know exactly where your data is located in the cloud provider of your choice. What I'll do is I'll create a file space called webinar, and I've got a selection of storage providers that I can choose from. I can also provide my other S3 compatible object store. However, in this environment, I'll select AWS and Frankfurt as my choice, the first choice. Once we create our file space, the LucidLink service is setting up the file space within our service for the customer. As Peter highlighted, each file space is a discrete service that we run for metadata coordination and accessing your file space client client synchronization. So it takes about 20 seconds for it to be prepared, and we're ready to initialize. We're going to host our data within S3 object storage. So we have our credentials, and we already have 6 buckets within our storage environment. So when it comes time to initialize, we'll need to install our LucidLink client. So you can download our LucidLink client for Windows, Linux, or Mac. I already have it installed, so I'll launch my client where I'll be prompted for my storage provider credentials. When I provide my credentials in the form of my access key and my secret key, I will then be asked for a root password. This root password stretches to AES 256 encryption string and enables our client-side encryption to secure the data within the object storage provider of your choice. So not even the object storage provider is able to access your data. Now that I've created my file space, I'm ready to open it and access it. So I can see on my Windows machine, I have a mount point called webinar. It is empty. If we go back to our S3 console, we can press refresh and we'll note we'll have 7 buckets. The bucket for our webinar file space is also empty. So to showcase our security, if we create a very simple file on our Windows machine called data, and within it, let's populate Windows data. We'll save it and we'll close it. And we'll note that when we press refresh, we will see an object. Now this object within the object store is protected with our encryption from the client side. So only the client has the keys. So even if you open this data, it is inaccessible on the client side. Inaccessible from the object store. It is only accessible, as we know, from the client side. So now that we've added some data, let's build a traditional file space layout to add our users and collaborate. I'll begin by adding some data, just a standard directory structure that you'd find in a typical environment with a users folder, And maybe I'll create a user called user1. And because we're going to collaborate with an external contractor, let's add a freelancer1 to our environment. Now, because we've added some users, or because we've added some data, we're about to add some users. Before we add our users, we want to highlight that from a data protection perspective, you can secure your data in the object storage provider of your choice, and you can also protect your data with our log structured unique block level file system. So we've got a choice of file space snapshots, whether they be manual or scheduled. I'm going to perform a manual snapshot right now because we've got our data layout, and then we'll proceed by adding some users. If we go into our dashboard, we can open up our user management, and within our user management, we're able to add a fresh user. Let's add user1 and provide their own password. And let's also add our freelancer1 with their own password. These are the users that we're going to use to access our data from our Mac OS machine and Linux machine. So we want to present them some data. Let's begin with just presenting both our freelancer and our user the data share with read write. We'll also add the user1 to the same share, and we'll create a share for our freelancer to have access to their own nested users folder with read write access. We'll leave our user as it is for the time being, and we'll connect with that user on our Mac OS machine. So we have our webinar file space. We know that we have a user called user1 and their own unique password. And when the file space mounts on Mac OS, we'll see the data that we have access to. We only have the data directory that we've provided access to. So now we can show how dynamic our user share access is. If we go into our user management, we can add a new share and add a share for our user1 to their own directory and add share, and you'll note it'll dynamically be available. So now within our Windows file space, we have our data folder, a data file. Let's take our data and move it into our data directory, and on our Mac OS machine, let's open up that data directory and contribute from Mac OS, close it, and then of course see within our Windows machine that that data is also available on the Windows machine. Now, because we've made a change from Mac OS, I want to perform another manual snapshot. That manual snapshot will trigger and we'll be able to join our Linux machine with our freelancer to our webinar file space. Freelancer1 with their own unique password, and they'll see the areas that we've shared to them, only the areas that we've shared to them. We see that they have their own read-write access to Freelancer, and they have their data access to the data text file that we've created, where we'll add Linux from the Freelancer. If we save that, if we look at Windows, we can see that add Linux has been contributed to. We can at this point create another snapshot to know that we've got the 3 different stages of our file space from all of our operating systems that have been contributing data. And we can look at what those snapshots look like. If we activate our snapshots, we will be able to see a mount point appear that will contain all of our snapshots. Now, these mount points are available across Windows, Mac, and Linux. I'm doing it on my Windows machine. Mac and Linux behave exactly the same. So we see our read-only snapshots that enable us to protect data from users that may have a ransomware attack or some other malicious or accidental event that causes data to become corrupted. So we can see this was our data layout at the time we did our first snapshot, with our data file in our root folder. If we open it up, we can see it contains the Windows data. If we move to snapshot 2, we note we had made a change. We'd moved our data file into our data directory, and we'd also contributed from Mac OS. So if we look at our snapshot number 3, we're expecting to see that it'll reflect our contribution from Linux. So we've demonstrated creating a file space, setting up a typical directory layout, our security model into the object store, how we write into the object store, and our snapshots through our log structured architecture that allows us to protect data. So let's look at how beneficial our architecture of how we use the object store in a unique manner. On my desktop, I have a 20 gigabyte video file. So this 20 gigabyte video file is going to take some time to copy to our data location that we know will be available to our contractor. However, because of the way we break up the metadata from the file data and we use the object store in a unique manner, as we start copying the data, we're caching locally and we're sending the data to the object store. So as you can see, we're sending some data. However, if we press refresh within Mac OS, in Linux, we can see some data is already available. So at this point, we can see that we've got 1.6 gig available in our cache to upload. We've got data in flight at the moment. And if we open this video file, we'll be able to note that the video file is already accessible from the Linux machine. We can start skipping through the video file and it plays as expected, even though the data has not been entirely ingested, because this data at the end isn't yet needed. Data is still in flight, but data is able to be read by the freelancer sitting on our Linux machine who could be anywhere in the world. And of course, they're reading and writing from the object store of their choice in a very efficient manner that enables them to stream data on demand and collaborate efficiently without having to synchronize whole files and wait for files to become available.
Hey, David, could I just interrupt you for a quick second? We have a question here asking how big a file can you share? Are there any limitations to it?
Theoretically, there is no limitation. We've just shared a 20 gigabyte file. We're going to break that file up into the object store in our unique block level manner. So if we do a refresh, we can see that we have a lot of compressed and encrypted block level reflections of what that 20 gigabyte data looks like in the object store. So to us, they are just additional objects in a scale out object store that we can access in our random access pattern of selecting from the metadata the particular objects the user and application need at the time.
We have a number of customers who are using it for that type of size of files as well. I mean, that's one of the beauties of object storage is its elastic nature and the fact that it can accommodate and grow on demand. Now, some of the object stores out there do have limitations for numbers of files in their buckets, but that's at a scale probably that doesn't worry most people at this point.
That's exactly right. That's right. And certainly not a problem considering the fact that you can have multiple file spaces and lay your data out in a very efficient manner that way.
Excellent. Thanks, David, for that demo.
You're welcome.
we've reached the 30-minute point. If there are any other questions, please feel free to type them in and we can answer them live. If not, feel free to type them in and we would follow up with you via email. And we will also make this recording available on our website. And with that, thank you all for attending and have a great rest of your day.